All right. Well, here's lesson 88. It's not lesson 87 like I put on the board, it's 88. But today we're looking at neutralization reactions. Neutralization reactions are the nitty gritty of what happens when I take an acid and a base and I put them together. This is going to lead us into lesson 89, which is our lesson about titrations. And titrations are unfortunately one of the coolest things I think we do all year in terms of seeing chemical reactions happen. I might try and do like a demo titration for you. You can go to any website and watch them do a sample titration if I don't get to it. The reason they're kind of cool is that they involve some color changes, and you're going from, a yellow to a green or a blue or something like that, or you might go from a clear to a bright pink, whatever it happens to be. But anyway, a neutralization reaction is a pretty simple reaction. The intro question, the chem catalyst, just says excess stomach acid, HCl, can cause extreme discomfort and pain. Milk of magnesia, MgOH2, is often taken to reduce stomach acid. So the question number one is, what products do you think are produced when Mg and Cl are mixed? Well, if you didn't have a whole lot of experience with this, you'd probably go, oh, well, I don't know. What the heck would it be? Well, when we look at an acid and a base coming together, and the HCl stomach acid is coming together with the MgCl2, or MgOH2, sorry, and that is a neutralization reaction. Basically, what the milk of magnesia does is it helps to remove a little bit of the excess acid that we get in our stomach sometimes because we ate something that upset our stomach or whatever it happened to be. We're stressing out, and that kind of stuff can cause a little bit of extra stomach acid. So the basics of it all in a neutralization reaction. Again, this is lesson 88. Are that an acid and a base come together, creating water and a salt. I just call that the general reaction. Okay, the generic, just run of the mill, what's going on? Acid base makes water and salt. Okay, now I've given you a more specific one. I've got hydrochloric acid. I'm coming together with sodium hydroxide. That gives me water. And again, this is a double displacement reaction. So Na jumps over here to Cl, H jumps over to the OH. And so when H jumps over to OH, we get water. When Na jumps over to Cl, we get NaCl. Again, we're changing our dance partner for these double displacement reactions. So that would be the chemical reaction that's taking place. And when was it? I can't remember. It was 17 or 15. We looked at what we called these complete ionic reactions. Well, complete ionic reactions show us all of the ions involved. So HCl is actually going to be in solution as H plus aqueous and Cl minus aqueous. The NaOH, sodium hydroxide, is going to be in there as sodium ion, Na plus, and hydroxide ion, OH minus. Again, both of them aqueous, telling us they're just floating around in some water. Well, again, we just swap our H to our OH, our Na to our Cl, and what we get here is water in liquid form plus sodium ion, aqueous, and chloride ion, aqueous. That would be our complete ionic reaction. But then we also talked about, well, what is the net ionic reaction? What is really happening here? And what is really happening here is that this Na and Cl are spectator ions again. Spectator ions don't do anything, just sit around. They're the same before, they're the same after, so they didn't do anything. But what really happens here, the nitty gritty of what happens, is the H plus ion gets together with the OH minus ion, and we create water. So Neutralization reactions are just double displacement reactions where one of the product is always water. Okay, the other product is the anion from the acid and the cation from the base. So the check-in question at the end was you take sulfuric acid and you combine it with magnesium hydroxide. What are your products? Write a balanced chemical equation for that. And so basically what's going on here, we've got two H's here and two OH's here. So two hydrogen ions, two hydroxide ions. That's going to make two waters. Okay. I have an Mg, which is a 2 plus. I have an SO4, which is a 2 minus. So they're going to get together as MgSO4. They're aqueous. Again, you should be going to look at these guys on page 459. How did I know this was aqueous? Again, I went to the table on page 459 from our chapter 17, lesson 90, I believe it was. And we saw that there's an S. When I look at Mg and SO4 together, those guys are going to create an S, which is a soluble salt, which means it's going to dissolve and it's going to be aqueous. If I saw one with an N there, again, that N would tell me that that would be a solid. And you will, on occasion, have some solids form. And then in that particular case, your complete ionic reaction and your net ionic reaction are the same thing because you're creating a solid and the water at the same time. So everybody is involved in the whole thing and nobody spectates. So I hope that helps with lesson 88. Again, tyrick at auhsd.net for any help. One more to go, and it's going to be our last lesson for the entire year. I know that's probably going to bring a tear to your eye, but we're getting close to being done here.